Welcome back to ABAGY Robotic Welding. We're posting regularly, so please subscribe so you don't miss a video. Today, we're going to get into welding parameters. And once again, we're joined by our expert, Demetrius.
Hello.
Hey.
Nice to meet you again.
Yeah.
So it's been a while since we had a big fun.
That's right.
With welding, right?
Yeah.
Do you want to continue?
I do. And it's going to be what kind of seam today?
Vertical.
So Demetrius, for today, why vertical? It's because it's going against gravity, right?
Exactly.
Yeah.
When you do welding in PA position, like this, your weld is, in terms of gravity, is in a perfect situation. The metal just stays where it comes in, and it doesn't float anywhere, right?
Yeah.
If you have vertical seam, then the metal which occurs here, it starts to float out below, okay? And that's the problem, because we want the metal to stay in the welding pool. So there are two ways how to overcome this situation. The first thing is that we may introduce weavings. Special thing how the torch actually do this
Weaving,
yes.
back and forth.
Back and forth, right? There are a lot of parameters of how we may do this. This actually helps us because it introduces, let's say, fusion between metals, not only in the center of the seam, but on the sides.
Great.
Okay?
And what's the second way?
And the second way is impulse welding, when we do the welding with a different power interval.
Yeah.
So at first we make the power big, and then a lot of metal floats out. But in order for the metal to hold in the position, we reduce the power, so it will like cool down. And this way we may achieve the same situation for the metal not to flow down rapidly.
Yeah.
I hope that we will show you today both of the ways, and also we will show straightforward way how to make the seam without any fancy techniques. And we will see that it will not be that good, okay?
So this sounds like a good set of challenges. The question is, why can't we just do it in the PA position to begin with?
Good question. So, in order to describe it, I would like us to go to the different workpiece. Okay? So vertical, because when you have this heavy, long beam, it's not easy for you to turn it on a different position in order to achieve this PA position.
Yeah.
So if the majority of the seams are horizontal, you may sacrifice some speed, but just avoid changing the position of the long beam. So that is why we need special welding parameters for the vertical seam to be also of good quality.
Yeah.
If you remember, in our previous videos, Mike tried to weld several seams.
Yeah.
And the seam was not like this had ideal form, right? Shapes.
Right.
And this is the advantage of robots. But this requires actually some change in welding parameters. Because when robot moves, it requires different speed of wire, different speed of gas, and so on. So this will require just some adjustment. And in order to describe it more, let us see how ABAGY software is integrated with welding machines and makes it possible to set up all of these parameters for the robots.
Great.
Let us make the weavings, which we discussed previously, in a different manner. So actually, weavings can be done differently. There are a lot of regimes we can do that. Try to imagine a triangle. In the triangle, you have, for example, the torch is moving here, from here, here, and back and forth, okay? And while it's moving back and forth, it actually slowly moving up or down. So how the seam is growing, okay? And so there are a lot of parameters. For example, you might need to stay in the center of this triangle here, exactly in the center of the seam, for the penetration to be bigger. Also, but if you stay for a bit longer, the metal will float.
That's
down,
right, yeah, too much goo.
That is why you need to move from the center to the side. And also you need to heat up the side wall in order for the fusion of the metals to occur, okay? So metal will stick to the wall. So another parameter is for how long you stay on the side. Also there is a parameter of how fast you move overall, okay?
Is it easy to choose these things on the system? How do you choose those things?
Well,
where are we?
You just go to the welding config and you see that the weavings are turned on and you have like type of weaving. We will use the triangle. There are a lot of different, for example, a spiral thing when the torch is actually moving like a spiral, slowly like floating in the, just moving in one direction. There is also a trapezoidal movement when the torch is going like that.
And and we just pick triangle, don't we?
Yes, we pick triangle, bang, boom. And actually there is, like for this triangle, as I described already, there are a set of parameters. One of them actually is the Z angle of the triangle. So you may do weavings in the manner of this, when the torch is not going up and down, just like horizontal here and then moves slightly. But you may actually make this triangle more triangle-ish, okay? And this is another parameter. So for now, I suggest us to run the default parameters and see whether we will like achieve everything without special settings or no.
Yeah, great.
Okay, we may go now.
Hey! Well, what do we have?
Let us take a look. You may actually know that at first glance, the seam is very nice.
Ooh!
Agree? So, but there is one problem with that. We did simplified version of weavings, which doesn't allow us to have a good penetration. You may see that for this seam, we have a pretty good, so the welding pool is penetrated into the metal, you see?
That's right, yeah.
But here, we don't have it.
Yeah.
Because the tool didn't stop exactly the position of the center of the seam. So this penetration is not there.
Right.
And in order to show you that, I would like us to go to our shop and cut the metal and see how the penetration actually differs.
Right.
Okay?
All right.
Yeah.
All right. Who's got a scissors?
Mike. Hello.
Hello.
So we need some help from you.
No problem.
You see, we have two welds here. One of the weld is good, well, because there is a penetration here, okay? And the second is not quite good. We believe that there is no actual penetration. So we want you to help us to prove that. So to cut the metal and see what's inside. So we see here that we will need to do some more exercise, okay? Because during our cutting, we don't actually see the exact penetration shape. So we will need to do some polishing on top of that.
But there's a lot of penetration here, and there's not that much there.
Yeah, but we cannot see this at the moment, you see, because of the cutting. So we will need to do polishing, and only after that we will see that. Let's do the polishing.
So let's have a look at this guy.
Yeah. So
Nice.
we've finished polishing, cutting and polishing, and now there are like tiny, small lines we need to distinguish. Let me show you. So take a look at this line. Okay? This is actually the place where the two plates meet. Okay? And our job was for the line to disappear.
That's right.
So for the pieces to become one. And we need to compare this line with this line.
Yeah.
Okay? And you see that this line is about 2 millimeters smaller than this one.
That's right.
It means that in the corner of our seam, there is a good fusion penetration. And here we haven't achieved that.
That's right.
And this is the difference, which is very important in terms of tensions in the metals for it to be.
And what were the different parameters you used to make this good one versus this bad one?
So with the bad one, we used, let's say, very straightforward weavings. Just from left side to right side without any special staying in the middle of the movement. But with this seam, we used a special thing, which we stayed longer in some position along the weaving. And the weaving itself is not that horizontal. It is different.
Like a zigzag.
Yeah.
Cool.
So it actually may take, for example, few weeks in order to find out the good welding parameters for your metals. That is why it might be quite expensive. So if you have these parameters already achieved here somewhere, it's maybe a good idea to buy it.
Can you store those parameters in the system?
Yes, you may actually store that and reuse with another robot in another situation.
So we have a good seam by weaving.
Yep.
And now
I suggest us to have two more welds. One weld with the weaving, with good weaving, and one weld with interval welding. and we will just compare how these two approaches to overcome the excessive floating of the metal due to the gravity will actually be different.
But is this not good weaving already?
It's good already, but I believe if we make another one, then it will be easier for us to compare within one detail.
Sure.
Okay, so I already have these two configurations set up in our program.
Yep.
I will just launch it.
So, question. I heard a kind of a siren sound there. What's that?
So it's not about police sirens, no. It's just interval welding. So the power increases or decreases. And you see, let us take a look at the seams. So they're both nice, right?
They smell nice.
And smell nice, right? Like a pancake, okay? But here we have actually a difference. First, convexity of the seams are different. This seam is more convex, and this is less convex. And this is internal welding. This is because in internal welding you don't have these weavings. You just stand in the center of the seam and then just the metal amount is which is floated away is bigger or less.
There's more glue in the middle.
Yes. So this is like welding arc pressure, and this makes the penetration.
Yeah, how's the penetration?
So we may not see it right now. Yes, but it is there.
Right.
Yes, and with these weavings, with the weavings, you see less convex shape. It is because when you move the torch from the left to the right in the special way, then more metal occurs on the sides.
That's right, yeah. That's
Okay,
nice.
and actually this type of welding of weavings, it may not be like it's not achievable on the manual if you use welding machines manual.
Right.
Because we do some more sophisticated movements because we control the position of the torch in each moment.
With the robot.
Yes. So this is actually more that you can get just from the weaving machine and its parameters.
Cool. And it's absolutely straight.
Yes.
Oh, good job.
Okay.
What's next?
I believe that's all for today. I'm already tired.
Working hard, both of you.
Yeah.
Thanks very much for watching. Please subscribe and put in some comments if you have any. We'll see you again. Goodbye from ABAGY Welding.
Peace.